All right, so here we are looking at Unit 7, Lesson 2, and our learning target for this lesson is to compare numbers on the number line. We have 4 intentions for this lesson. One is to explain how to use the positions of numbers on a number line to compare them, to explain what a rational number is, to use inequalities to compare positive and negative numbers, and to understand what it means for numbers to be opposites. We're going to start with a which one doesn't belong, and here we are looking at inequalities. Inequalities meaning things that are not equal, and you can see that within the word itself, in and then equality. So here, not equal. And the question here is, well, which inequality doesn't belong and why? So take a moment to choose the inequality that you feel mostly doesn't belong. And once you clicked on your selection, please take a moment to explain your thinking, why you chose that one, and share that with the class. This might come as a reminder to you, but here we have those symbols for greater than and less than, and we have our equal to symbol as well. Remembering that the greater than symbol, as we're reading in English from left to right, we can see here that the greater than symbol starts up where it's spread open more, and it gets smaller and smaller and smaller, so it's greater to begin with, and it gets to a smaller point on the inside of the mouth of this alligator. And the less than symbol, again, as we read from left to right, we can see again, we're starting here where it's a smaller point, and it does get larger and larger and larger, meaning if we're starting with a smaller point going from left to right, I can read this as my less than symbol because it opens up to a greater amount. Taking a look at what a rational number is, because we are going to be looking at rational numbers throughout this unit. This whole unit is called rational numbers. Do you know that a rational number is a fraction or the opposite of a fraction? For example, 8 and negative 8 are rational numbers because they can be written as 8 over 1 and negative 8 over 1. And you have a second example there with 0.75 and negative 0.75, because here we can see that we can rewrite this decimal as the fraction 75 hundredths and negative 75 hundredths as well. Taking a look at activity 2.2, we are now comparing temperatures. Here are the low temperatures in degrees Celsius for a week in Anchorage, Alaska. We're going to start here at 1A, where we're asked to plot the temperatures on the number line. So here, taking a look at the temperatures on this table, I can see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I see the temperatures for Monday, for example, is 5, and this is in degrees Celsius. So this is 5 degrees Celsius on Monday. I can see, for example, Tuesday's temperature is negative 1 degrees Celsius. And so here, I'm going to go ahead and plot these temperatures, starting with Monday. I'll start from 0, and I'm going to go to the right 5 because it is a positive 5. So 1, 2, 3, 4, 5. And again, when we're plotting on a number line, we do want to make it so that way our dot is on the line. We don't want to put it above the line. We're not trying to make any lollipops, right? It kind of looks like a little lollipop when it's kind of hovering over that tick mark. Instead, we do want to make sure that we're plotting it correctly by putting it on the number line itself. Tuesday is at negative 1, so I'm going to take Tuesday, I'm going to start at 0, and I'm going to go 1 to the left to get to negative 1. Wednesday is at negative 5.5, so I'm going to start at 0 and again go negative 5.5. So 5.5 to the left of 0, starting here with 1, 2, 3, 4, 5. Notice I still need to go 0.5 more, so I'll go half more. So negative 5.5 really should be between negative 5 and negative 6. Negative 2 for Thursday. So here I'm going to take Thursday, so I'm going to drop it over to negative 2. That's 2 to the left of 0. Friday is at positive 3. Let's go ahead and just put it right over here to positive 3. Saturday is at 4. And lastly, we have Sunday at 0. So it's not moving anywhere from 0. It's going to be right on 0. Okay. And so now we're asked to answer this question, which is which day of the week had the lowest low temperature. And in this case, I can see that the lowest low, these are all low temperatures in Anchorage, Alaska, and the lowest of them all, I can tell right away, is Wednesday. Without having to look at all these numbers anymore, I can see Wednesday is the lowest, and I can tell that because it is the one that is furthest to the left on my number line, and I know that anything that is further to the left of others on a number line is going to be the least of those amounts. So here I can say, for example, Wednesday is the lowest low temperature. I know this because it is the number that is furthest to the left on the number line. Continuing on to slide 8, I can see here that we have a new question that we're looking at. And here we're asked that, or we're told that the lowest temperature ever recorded in the United States was negative 62 degrees Celsius in Prospect Creek Camp, Alaska. The average temperature on Mars is about negative 55 degrees Celsius. So answering question 2a, it's asking, well, which is warmer, the coldest temperature recorded in the US or the average temperature on Mars? And explain how we know. So in this case, I'm going to go ahead and pull up a Jamboard. I can go to this by going to jamboard.google.com. And here I'm going to be plotting and creating a number line so I can plot these two temperatures. Again, negative 62 degrees Celsius for the place in Alaska, and negative 55 degrees Celsius for Mars. So here I can draw my number line. I'm going to give just some approximates here in this case. For example, I know I don't need to have all the positive numbers because the two numbers I am plotting are going to be negative. So I'm going to even start by putting 0 over on this side. Okay, and let's go ahead and make a few tick marks, and we'll go by tens simply because, well, we need to get down to 62, right? So here, this would be negative 10, negative 20, negative 30. So I'm going 30 away from 0 to the left, negative 40, negative 50, negative 60, and negative 70. And so obviously this can continue going on, but I'm going to stop it right there. And so plotting first, I'm going to plot for in Alaska, we said that the temperature recorded, lowest temperature recorded in Alaska was negative 62 degrees. So negative 62, here's negative 60. I still need to go negative 2 more away, so 2 more to the left. So about here would be about negative 62. And this would be for the place in Alaska or USA. And the average temperature on Mars, do you recall, says that it was at negative 55 degrees Celsius. So here, from 0, I'm going to go negative 10, 20, 30, 40, 50. I still need to go 5 more to get to negative 55. And here I'm at negative 55 degrees Celsius. And here, again, this was for the average temperature on Mars. So answering the question that we have now, it's asking which is warmer, the coldest temperature recorded in the USA or the average temperature on Mars. Explain how you know. If we're looking for the temperature that is warmer, our goal then would be to look for the one that's not furthest to the left, because these ones again represent the cooler temperatures, right? The further we go to the left, the temperature does get cooler. And the further we go to the right, then the temperatures would be warmer in this case. So the one that is warmer would be the one further to the right, or in this case, Mars at negative 55 degrees Celsius. So here, which is warmer? The average temperature on Mars is warmer. I know this because on a number line, there we go, negative 55 is further to the right than negative 62 is. And so now I can actually write an inequality to show this answer. So here, writing my inequality really is writing using those alligator symbols, using those greater than and less than symbols. So in this case, I'm going to look at my warmer temperature, which is negative 55. Okay, and I'm comparing that again to my negative 62. And so I want to figure out, well, which symbol am I going to be using, the greater than symbol or the less than symbol? We said that this number is warmer, and so we know this is greater, so my symbol should open up where the 2 points are further apart or a greater distance away. You'll notice since this is our smaller number, it gets closer and closer and closer and closer until we get to a smaller point at the very end here. So here, negative 55 is greater than negative 62. And so I can type that in. Negative 55 is greater than negative 62. On to slide 9. On slide 9, we see here that on a winter day, the low temperature in Anchorage, Alaska was negative 21 degrees Celsius, and the low temperature in Minneapolis, Minnesota was negative 14 degrees Celsius. And so Jada says, I know that 14 is less than 21, so negative 14 is also less than negative 21. This means that it was colder in Minneapolis than in Anchorage. Do you agree? Explain your reasoning. Please take a moment to take a look at this, reread it, reread the information that we're given, and really decide whether or not Jada's full statement is correct. If you agree with her, please explain. If you don't agree with her, please make sure you mention that and also explain as well. Okay, in this case, we really should be disagreeing with Jada. So here I can say I disagree. And you might notice that her first portion of her statement is true. She says, I know that 14 is less than 21, which is true. 14 is definitely less than 21. However, the second part of what she says here says, so negative 14 is also less than negative 21. Isn't quite correct, right? And one of the ways we can explain this might be that on the number line, negative 14 is closer to the positive numbers than negative 21. Positive temperatures we know are warmer than negative temperatures, so this means that negative 14 degrees Celsius is warmer than negative 21 degrees Celsius. You could have also mentioned instead the fact that, well, negative 14 we know is further to the right on the number line versus negative 21. Negative 21 is further to the left if you do plot these on the number line. And if we know it's further to the left, we know it's going to be colder, which is definitely not what Jada is trying to get at here. Taking a look at slide 10, it just kind of gives us that same information, right? In this case, we see and we know now that, at any time we're going further and further to the left on the number line, we are looking at temperatures that are colder, and we are looking at numbers that would be getting less and less. Anytime we get further and further to the right on the number line, it becomes a warmer temperature, or in this case, we're looking at numbers that become greater and greater. Please notice that we can have a number that is greater than another, even though they are both negative. For example, I could have negative 10 over here, and I could have negative 1 over here. Negative 1 is still going to be greater than negative 10 because it is further to the right, although it is still a negative number. So that's possible as well. Moving on to slide 11, we are now looking at activity 2.3. And now we're looking at some other rational numbers on the number line. And so we're going to start by plotting these numbers, negative 2, 4, negative 7, and 10 on the number line. So here, plotting these, I'll start with negative 2. I notice that I have a 0 here, and the first tick mark over right next to it is a 1, meaning I know that each of these are going by 1s. And that means going to the left, I should have negative 1, negative 2, negative 3, and so on. So here, from 0, I have negative 1 and negative 2. I'm going to go to the left. Over here for 4, starting from 0, I'm going to go 1, 2, 3, 4 to the right, because it is positive. Starting from 0 for negative 7, I'm going to go to the left since it's negative, and I'm going to go 7 to the left. So 1, 2, 3, 4, 5, 6, and 7. And lastly here, positive 10. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we make it all the way to positive 10 on our number line here. Okay. If you scroll down, you'll notice there is some questions that go along with our number line we just completed here. It says to select all inequality statements that are true and be prepared to explain your reasoning. So in this case, I have -2 is less than 4. Here's -2, and it is further to the left compared to 4, so that is a true statement. -2 is less than -7. Here's -2. Here's my -7. It is further to the right. And so this statement is not true. It should be that it's greater than. I should have the opening up to the alligator opening up to our -2 instead. Here we have 4 is greater than -7. 4 is definitely to the right more compared to our -7. So this is greater than, and that's true. And we have that -7 is greater than 10. Well, if we have a negative number compared to a positive number, we know all the negative numbers would be to the left of 0 and all our positive numbers are to the right of 0, meaning that -7 must be a number that is less than our positive 10 in this case. So this is incorrect. I'm not going to check that one. Taking a look at slide 12, we are now looking at some more rational numbers on the number line. And we're going to start by actually going to this site right here and using this to help us compare and answer these questions. All right. So clicking on this site, again, I know I'm working on 2.3 and it's in question 3. So I'm actually going to scroll down from here and find 2.3. There it is. Rational numbers on a number line, and we're looking at question 3. So here's question 3, and we're going to use this right here to help us answer the question. The question says that Andre says that 1/4 is less than -3/4 because of the two numbers, 1/4 is closer to 0. Do you agree? Explain your reasoning. So here we're going to look. We see here there's 1/4, and I can plot 1/4 on my number line. It is a positive number, and well, let's see where it goes. It's not going to be 1 whole, and let's actually help us out by showing more of these divisions of each portion. I'm going to subdivide this 1 into halves first. Halves are helpful, but it might be better since we are looking at fourths, 1/4 and -3/4. Maybe if I actually show quarters instead. Right, so here I have 1/4, 2/4, 3/4, and 4/4 to get to 1. So positive 1/4 is what he's looking at, and so I can plot that there on my number line. And he also says -3/4, so here's my -3/4, and since I know it's negative, I'm going to go to the left, and here's -1/4, -2/4, -3/4. Checking his question now. Okay, it says here that Andre says that 1/4 is less than -3/4 because of the two numbers, 1/4 is closer to 0. So here, 1/4 is closer to 0, but again, if we're looking for greater than or less than, what does matter is not how close it is to 0, but which of those numbers is further to the left will be the number that is least or the less of the two. In this case, the one that is less is going to be -3/4. So here it should be that -3/4 is less than 1/4 because it is further to the left on the number line. So looking back at my Desmos tabs here, I can again just add into this that I disagree. And my reasoning is that -3/4, I can change that to look like a fraction by using my math tool here. -3/4, there we go. I'll hit my arrow to the right so I can get out of that box. And I can say that -3/4 is less, right? Andre says that 1/4 is less. -3/4 is less than 1/4. Let's change that to look like a fraction again. I'll hit my math tool, and I'll do 1/4, and I'll hit to the right again, so that way I'm out of that box. So -3/4 is less than 1/4 because it is further to the left on a number line. Now, it would also be correct to say that 1/4 is greater than -3/4 instead. We're just looking now, instead of which one is further to the left, we're looking at which one would be further to the right. So do look at how you word yours. As long as you have a reason that is correct and makes sense, then your reason might still be a little different than what mine is too. We're going to continue to use this same tool on our Illustrative Maths website here. And so if I continue to the next slide, on slide 13, we're asked a few other questions, and we're looking to see again which is greater and which is less, or in this case, which number is greater and then which number is farther from 0. So going back to this tool, we have those same numbers here. I'm going to scroll down here just a little bit so we can see each of that also. So here we have which is greater, 1/4 or 5/4. So here we have 1/4 already plotted. 5/4 I can plot by putting 1/4, 2/4, 3/4, 4/4, and 5/4. So here, which number is greater? Well, if it's going to be further to the right, it must be 5/4. So here, of these two, 5/4. Now, which number is farther from 0? Take a look. Take a look here if you need to also. Of these two numbers, the same numbers, which is farther from 0? Yep, 5/4 is 5/4 away from 0, where this is only 1/4 away. So in this case, 5/4 is also farther away from 0. So in this case, the greater number is also the number that happens to be farther away from 0. I take a look at slide 14 now. I'm comparing a few other numbers. This time I'm looking at some eighths and some fourths also. So we're going to be plotting -3/4 to find which number is greater, and plotting 5/8 also, and then we're going to be looking at those same two numbers to see which number is farther from 0 this time. So -3/4 and 5/8. Here's my -3/4 already plotted, and 5/8. Ooh, let's show some eighths instead, right? So here I'm going to go to 5/8 by putting that 1, 2, 3, 4, 5/8 away. And here now, let's see, which one is greater was the first question. Again, we're going to start by looking to see which one is greater by looking at which one is further to the right. In this case, I see that positive 5/8 is further to the right, so 5/8 would be correct there. And which number is farther from 0? Well, let's take a look. Here I have, this is 5 jumps away, well, 5/8 of a jump really away from 0. And you'll notice here that I'm taking more of those eighths away to get to -3/4. So here this is 1, 2, 3, 4, 5, and 6/8 really in order for me to get to -3/4. So I'm jumping a little bit further away. So in this case, the number that's further is actually -3/4. And you'll notice now that even though it's not the greater number, this one is not the greater number, right? It actually is the one that happens to be farther from 0 because it is going a greater distance. It's just going in the negative direction. So it's not a greater number, but it's going further away in that negative direction instead. And looking here to our last slide of this section, we're asked basically, is the number that is farther from 0 always the greater number? Explain your reasoning. And just like we saw in the last two slides, you can go back to them if you need to. You can see that sometimes it is and sometimes it's not. So please just take a moment, answer yes or no. It's asking if it's always greater than the number, and it's asking, is the number that is farther from 0 always the greater number? Go ahead and answer yes or no and explain your reasoning behind that. And like we noticed here again, we see that it's not always, and I can say basically no because numbers to the right are greater than numbers to the left. And so sometimes, for example, it is going to be greater if it happens to be further to the right, but we saw, for example, that it's not always going to be further to the right. All right, we are down to the last few things. Take a look at our lesson here. And I really want you to see whether or not you can use these as a self-check for yourself. Basically, check the boxes of the questions that you can answer with confidence. And if you do have questions, make sure you write them down. So that way, when you have the opportunity to, you can ask these questions and hopefully understand it even better than your current understanding is right now. Lastly, please work on your own to complete slides 17, 18, and 19. 17 is part of a cool down activity. This is, again, an independent assignment. It is something that is going to be looked at and graded. I want to see where your current understanding is based on this cool down. All right, again, here you're writing some inequalities you can see. So use your less than or your greater than symbols, please. And you have the information here to tell you which numbers you would be using as we were creating these number sentences, these inequalities, okay? Over here, so what this means is that you're not going to be writing in Death Valley and Tallahassee. For example, you wouldn't say Death Valley is greater than, or you wouldn't say it's less than. Instead, you would actually use the number for it. So here, negative 282, and then you would tell me is greater than or is less than, and tell me the other number, basically, that would make this a true statement, okay? On slide 18, you'll notice here that we are looking at a number line. And on this number line, let me tell you this first. On this number line, we have your point A, point B, point C, and 0. And point B and point C are what we call opposites. And we've been working with opposites this entire time. Anytime you're looking at a negative number, it's the opposite of one of our positive numbers. Opposites really are just numbers that are the same distance away from 0 on a number line. So for example, 1 is 1 away from 0. Well, we're going to go 1 away the other direction, and we're at negative 1. So meaning the opposite of 1 is negative 1. Here, let's say the number 10. Well, that's 10 to the right of 0, and so we can go 10 to the left of 0 to fall onto negative 10. So that means that 10 and negative 10 are opposites. What do you think is the opposite of 50 then? Negative 50. Right. What do you think is the opposite of 99? It would be negative 99. And the same is true even if you start in the opposite side of it. So if I start at negative 4, well, I'm just 4 to the left of 0. Oh, I just go 4 to the right of 0, and now I'm at positive 4, meaning that negative 4 and positive 4 are opposites. And so here, I'm going to look to select, well, which I can figure out are true based on this information. So here I know A is, well, I can see that it is further to the left, for example, than all of them. I see that 0 is right over here. And I know that if B and C are opposites, I know they must be a certain distance away from 0 also. Use what we've just talked about right here. Use what we've already been working with our number lines right now too, to help answer and select all the statements here that you believe are true. And don't worry if you get any of these incorrect at this time. We're just starting into this idea of opposites. We're going to be continuing with this idea of opposites as we continue into lessons 3 and 4. All right, so do your best with this one. And then finally on slide 19, just give me a quick check on your confidence. How do you feel on all our different learning intentions that we looked at from earlier in this lesson? Give me some stars telling me where your level is at with the confidence on these ones. And maybe just tell me, for example, if you're at a 5, how do you know for sure you're at a 5? If you're at a 4, well, why aren't you at the 5? Give me a little bit more information about that and hit submit, please.